NCBM 0324, Section 1.2, Solving Linear Equations in One Variable, Part 1. In our last section, we discussed the order of operations and how we use that specific order in order to evaluate expressions. One of the last things we saw in that section was the difference between an expression and an equation. Well, in this section, we're going to take the idea of equations and go a little further, and we're going to talk about solving equations, more specifically, linear equations. We'll see quite a few different types of equations in your Math 1324 class, and this is just going to be one of the most basic types of equation. We'll start off here. So solving linear equations, we'll say an equation can be written into an equivalent equation by one or more steps listed below. So sometimes we're going to need all of these steps. Sometimes we're only going to need a few of them, but knowing that they're all available to us is really helpful. So the first thing we can look out for, and we can try to do, is to multiply on both sides of the equation by the LCD. That's the least common denominator, and we can do this to clear out the equation of any fractions that may occur. While we can work with the fractions within our equation, it might be easier for us to clear out those fractions and work with whole numbers. So using that least common denominator, we can eliminate the fractions from our equation, right? And this works again because it is an equation. The second thing we can try is to use the distributive property to remove any parentheses if they occur. So after getting rid of the fractions, let's look to see if we have any parentheses. If there is any, we'll use that distributive property. We'll multiply anything in front of the parentheses all the way through to clear out that notation. Once we have the parentheses out of the way, we're going to simplify each side of the equation by combining like terms. We did this a little bit at the end of the last section. And when we say combining like terms, we mean if there's any variables, we want to group them together. Let's simplify that side of the equation. If there's any variables, any constants, any numbers without the variable, we're going to gather those together as well. Then, number 4, we're going to get all variable terms on one side and all number terms on the other side. So we've simplified each side. Now we're going to start to move things around across the equal sign. So we're going to get all the variable terms, all the number terms on the other side. And we're going to do this by using the addition property of equality. And that addition property of equality simply says if I add something to one side and I add it to the other side, that equality still holds. And this is also going to be true not just for addition, but also for subtraction. If I subtract the same value on each side of my equal sign, that equal sign is still true, right? It's still a valid equation there. So we have all the variables gathered together. They're on one side now. My numbers, stuff without a variable, is on the other side of my equal sign. Now, how are we going to get that variable by itself? We're going to get the variable alone by using another property, the multiplication property of equality, which is very similar to the addition one that we saw in step 4. The multiplication property of equality says that if I multiply or divide both sides of the equation by the same quantity, the same amount, that equal sign is still going to hold. And that's going to be our goal. We want to get that variable by itself. So we're going to divide or multiply away any coefficients it may have to isolate that unknown value. And that's what it means to solve an equation, right? We're finding the value that's going to make that equal sign be true. In fact, Once we have an answer from step 5, something that's really nice about solving an equation is we can always check the solution. So no matter what type of equation we're working with, we're always able to make sure our answer is actually correct. And we're going to check the solution to these linears by simply taking our answer and substituting into the original equation. And when we substitute it in, we have to make sure that the left side is equal to the right-hand side, right? That equal sign, that equality holds, right? It's satisfied there. Let's try a couple. Example 1, solve. So already here you can see how our instructions are changing, our directions are changing. In our previous section, we were asked to evaluate. They gave us a string of numbers with all kinds of operations, and we found all the simplification of that. In these cases, when we're asked to solve, we're going to have some sort of statement, x equals, y equals, whatever the variable is. And when we're solving, we're trying to figure out what is that number that's going to make that equation balanced, that's going to make that equation the equal sign, in fact, true. So let's look at example A. We have x plus 11 is equal to 15. Pretty straightforward. It's an equal, so I know it's an equation here. And my unknown that I'm trying to solve for is the x. I want to get the x by itself. So if I look through my options to solving my linear equation, I don't need an LCD because I don't have any fractions, which is good. I don't have to use the distributive property because I don't have any parentheses. Let's check our combining like terms. Well, this is my x, it's the only one, so it's good. This is a constant on this side, it's the only constant on the left side. 15 is the only one on the right, so that's done. But then we get to step 4. Now we want to start moving things around. Remember, we want the variable terms, anything with a variable on it, on one side of the equation, and all the numbers, the constants, on the other side. And we're going to do this with addition and subtraction to start here. So I do have a plus 11. So in order to move that to the other side, I'm going to do the opposite sign. So instead of plus 11, I'll do minus 11. And how do we undo addition? We subtract. And what I do to one side, I have to do to the other to make that equal sign be balanced. So then I can simplify. On the left, then I have the x. The 11 cancel away to 0 there on the left side. And on the right side, I'm going to have 15 minus 11, which gives me 4. Fourth step is done. My variables on the left, my constant, my numbers are on the right. Then I can try my fifth step, although reading what we have, the x is already alone. Right? We're trying to get the variable, which is the x alone, and it already is. So and this looks to be our answer. But if we're uncertain, or if we just want to get into this habit, which is good, we can always check, right? Check our answer. So if we do the check, I want to make sure that x equals 4 is my solution. I'm going to take that 4 value, I'm going to plug it into my original equation and see if it's true. So I'm asking myself, is 4 plus 11 equal to 15? And yep, it is. That one's easy. So we can say for sure that yes, this is our solution. X equals 4. Let's try B. We have 7x plus 2 equals 25. Let's go through the same steps. Any fractions? Nope, so no LCD. There's no parentheses. All my terms are combined on the left side, right? I have a variable term that can't be combined with the 2 because the 2 doesn't have the x. So they're good, they're simplified. 25 is the only thing on the right. Okay, step 3 is done, right? This third thing we check. And we'll start moving things around. So I get my variable terms on one side, my numbers on the other. So once again, I have a plus, in this case 2. So I'm going to undo that with subtraction. And what do I do on one side? I have to do to the other. So that cancels away on the left, leaving behind 7x is equal to 23. 25 minus 2 is 23. So fourth thing is done. And now let's look at the fifth one. A little different than part A because my variable isn't by itself yet. It has this 7 in front. And in fact, when we see 7x like this, it's really going to be interpreted as 7 times x, right? Instead of writing that multiplication sign or saying it 7 times x plus 2, right? We just simply say 7x. But there is multiplication happening here. So by that multiplication property of equality, to undo the multiplication, I'm going to divide. The division undoes multiplication. And 7 divided by 7 is simply 1. 1 times that x that was on the left side, still there, is simply x. And then on the other side, 23 divided by 7. Now I'm just going to leave it as 23 divided by 7. We're not going to round. We only ever want to round unless the problem tells us to. And it'll usually tell us how many decimal places to use as well. So careful with that. So it looks to be my answer, but let's make sure. It's never a bad idea to check. So I'm making sure that 23 over 7 makes this original equation true. So if I do 7 times 23 over 7 plus 2, does that equal 25? Well, looking at my left side, that's where my order of operations comes in. You can already see how we're using that. I'm going to multiply these values first. I'm going to think of this as 7 over 1. Because if I multiply fractions, I multiply straight across. But I notice here that I'm going to eventually have to deal with this 7 up top, and there's a 7 on the bottom. And what is 7 divided by 7? That's simply 1. And the 1 times the 23, right, there's another 1 down there. 1 times the 23 is just 23 plus 2. Does that equal my 25? And in fact, it does. So our answer is good. Our answer is 23 over 7. One more. We have on part C, 3 parentheses x minus 5, close parentheses, is equal to 3. So checking my rules. Again, I don't have a fraction, so that part's cleared away already. I do have parentheses though, so I'm going to have to take that 3, this is the coefficient, and I'm going to multiply through everything inside of those parentheses. So then that gives me 3x minus 15 is equal to 3. Notice this 3 on the outside here. It's not part of the parentheses, so it doesn't get that multiplication. Just what's inside of those parentheses gets it. And then we go with our next step. Combine like terms. Okay, everything looks to be combined. But then I can start moving things over the equal sign. So here I have a minus 15. So undo subtraction with addition. And that leaves me with 3x is equal to 18. Use that multiplication property of equality. This is being multiplied. 3 times the x. I want to get rid of that 3. So I just want my variable alone by itself. 3 divided by 3 becomes 1. 1 times the x is just simply x. And 18 divided by 3 is 6. So it looks to be our answer, but let's check to make sure. X is equal to 6. Let's see, 3 times 6 minus 5. Is that equal to 3? Order of operations, 6 minus 5 is 1. And is 3 times 1? Well, that's 3. And it does equal 3. So that is our solution. So nice, helpful path to take. Sometimes we need some of these operations, sometimes we don't. Let's look at more examples.